Hello guys, you are welcome. Let's solve this question. It reads the terminal side of an angle theta in standard position passes through the point -3, -4. We have to find the values of the 6 trigonometric functions of the angle. Join me and let's solve it. Good. Solution. First, you are going to draw your Cartesian plane. So this is my Cartesian plane. This is my y-axis, my x-axis. Very good. So where are you going to locate this point? They said it passes through the point -3, -4. So your first move is to locate your -3, -4. So -3 on the x-axis will be found somewhere here. These are the positive x-axis, negative x-axis. So our -3 will be found somewhere here. Let me write it well. -3. And our -4, that's on the y-axis. Negative will be found somewhere here. So -4. So -4. So meaning our point will be found somewhere here. That's -3, -4. After doing this, this is the terminal side of the angle theta in standard position, meaning is from where? The origin, which is passing through the point. So from the origin, passing through the point, that is standard position, which makes an angle on the x-axis, always on the x-axis. The angle should be always on the x-axis, not the y-axis. Always on the x-axis. Well, we take note of that. Okay. So meaning from this place to this place will give us 4 units. 4 units. Meaning from this length will give us 4. So from this to this will give us 4 units. So 4 units. And also from here to here, the distance, the length will give us what? 3. Distance or length are not measured in negative, so they are positive. So from here to here will give you 3 units. From here to here will give you 4 units. That's why I've written 3 here and 4 also here. In this case, the question says trigonometric functions. 6 trigonometric functions. Trigon means triangle. Trigon in Greek means triangle. Metron in Greek means measurement. So trigonometric, triangle measurement, meaning we need a measurement of a triangle here. So I can join this to form a triangle. By in this case, a right angle triangle. So this is a right angle triangle which is being turned upside down. Okay, that's good. It's still a right angle triangle. Okay, now you know your length for this side and this side, but you don't know this side, the third side. You know whenever you're having 2 sides and 1 unknown side, the only way you can solve this, or the best way you can solve this, is using the Pythagoras theorem. Okay, so let's do that. Pythagoras reads that hypotenuse square. So h square equals opposite square. Let me use O. So O square plus adjacent, let me use A, so A squared. So H squared will be equal to opposite. Where is the opposite? Where the angle is facing, the length the angle is facing is your opposite, so 4. So 4 squared plus adjacent. Adjacent squared, this is your adjacent, is adjacent to the angle 3. So 3 squared. So h squared equals 16 plus 9, which will give you 25. So h squared equals 25. Now how are you going to get h? You are going to square root both sides. So square root will cancel square. So our h will be square root of 25, which is 5. So 5 units. 5 units. So meaning our hypotenuse, which is the longest side, is 5 units. So 5. We now have our 3 sides. Let's write the data down. So our hypotenuse, which is 8, equals 5. Our opposite facing the angle is 4. Opposite is 4. And our adjacent is 3. So our adjacent equals 3. After doing this, then you move ahead to your ratios. For you to remember the ratios, you have a mnemonic known as SOHCAHTOA. So SOHCAHTOA. It helps a lot to remember the functions and its ratios. Okay, so sine its ratio is opposite hypotenuse. So sine written in its short form, so sine theta equals opposite over hypotenuse. So cos theta equals adjacent over hypotenuse. So A over H. And our tan theta equals opposite over adjacent, O over A. After doing this, the next move is to plug in your values. So you can see sine theta, which is opposite over hypotenuse. So opposite is 4, hypotenuse is 5. So 4 over 5. Good. Cos theta, which is adjacent over hypotenuse. So 3 over 5. Good. Tan theta, which is opposite over adjacent. So 4 over 3. 4 over 3. So after doing this, then you go on to check where the point which is being given, where it falls in the Cartesian plane, which quadrants. Remember that trigonometry we measure in anti-clockwise direction, not in the clock direction, but anti-clockwise. So this way. So meaning this is your first quadrant, your second quadrant, your third quadrant, and your fourth quadrant. So in this case, our point falls on the third quadrant. And for you to know which of the ratios should be negated, we have a rule known as the CAST rule, C-A-S-T. It's also a way of remembering which of the ratios should be negated and which one of them should be what? Positive. Okay, so you can see that our quadrant is the third quadrant. This is our third quadrant, so 1, 2, 3. There's T here, meaning our tangent or our tan should be positive and the other two ratios should be negative. So here our tan should be positive and the other two ratios, that the sine and cos, should be negative. So sine and cos should be negative. Sine and cos should be negative. Our tan remain positive. So that's it. Very, very simple for the three ratios. But the question says 6 trigonometric functions. That's the reciprocal of the three functions. So what's the reciprocal function for sine theta, which is cosec theta, cosecant? Some shorten it as cosec and some shorten it as CSC. So let's use the CSC. Theta equals reciprocal, that's 5 over 4, negative 5 over 4. And the reciprocal function for cos theta is sec theta. So you reciprocate it or you flip it. So 5 over 3, which is being negated. Okay. And the reciprocal function for tan theta is cos theta. So it will be 3 over 4. which is not being negated, positive. So this is the values for the 6 trigonometric functions. Very, very easy. If you like this video, please share it among your friends. Thank you very much.